I'm Tom McHugh from GSI Environmental.
And I'm Chuck Newell, also from GSI Environmental. This is one of a series of videos that highlight cutting-edge CERDP and ESTCP R&D efforts. Now today, we'll be looking at a topic in the environmental restoration area. We'll be talking about ways to figure out if vapor intrusion is an issue at your site and how to determine what the source of this vapor intrusion is.
Specifically, we'll be talking about methods that will help us identify the source of contaminants in indoor air. Here's a summary of what we'll be discussing today.
Now the problem is that if you've got poor indoor air quality and you think that vapor intrusion is the cause, then this can be a challenging and costly thing to fix. But before doing that, it would be smarter to figure out if the groundwater plumes are really the cause of the problem.
So a lot of progress in identifying sources of indoor air contaminants was made during several ESTCP-sponsored projects. And we'll focus today on one titled, Using Real-Time Compound-Specific Analysis to Distinguish Between Vapor Intrusion and Indoor Sources of VOCs.
Okay, now the PI, the principal investigator on those projects, Dr. Tom McHugh, and you've already introduced yourself. But some of the other collaborators include Kyle Gorder and Eric Dittmeyer from Hill Air Force Base, Ignacio Rivera Duarte from the Navy, and Lila Beckley from GSI.
A key point from this project is that indoor air testing is important for accurately conducting vapor intrusion studies.
And second, there are these newer on-site analytical methods that provide real-time information, and that's really critical for these types of indoor air monitoring studies.
And then, as we'll see in a minute, real-time testing will not only tell you the amount of VOCs in the air, but they will help identify where those VOCs are coming from.
Okay, cool. But to start out, though, I think it's worthwhile we define what we mean when we say vapor intrusion. So imagine you've got this house here, and there's this chlorinated solvent plume in the groundwater underneath the house, and vapors potentially may be coming up from the groundwater through the vadozone and into the house. So our definition is that vapor intrusion is the vapor phase migration of volatile organic compounds from the subsurface into indoor air. And our real question is, do these vapors have an effect on the air quality inside that house?
So a few years ago, indoor air testing was considered to be a simple way to confirm the presence or absence of vapor intrusion in a building. In other words, when the groundwater contaminants were detected in indoor air samples, then vapor intrusion was assumed to be the source. But this conceptual model was based on the perception that chlorinated solvents aren't used anymore outside of a few industrial applications. It was thought that household products could not be the source of poor indoor air quality.
Now, I was definitely under that impression for a while, but it turns out I should have been reading the labels of these consumer products a little more carefully. You don't have to look that hard to find these products that do contain chlorinated solvents. We're going to show one here. The first one is a lubricating oil that you can buy and you might use in your garage, around your house. But if you take a look on the contents on the back, there it is. We've got perchloroethylene, PCE, listed in the ingredients.
A few more examples of indoor sources. There's a popular hobbycraft glue that also contains PCE. There are some other examples. There's gun cleaner and pepper spray. Both of those can contain trichloroethylene or TCE.
Okay, so those are some good examples of consumer products that have our groundwater contaminants that we typically focus on in these products themselves. So what's important to remember here is that if you're trying to design a protocol for investigating vapor intrusion, you better make sure that your program accounts for the potential contributions of indoor air sources like these.
I think you're right, Chuck, but I think it's also important to acknowledge that once people realized these consumer products could show up in indoor air testing, many investigators tried to avoid indoor air testing altogether. They were saying that the data is too confusing to use and that sub-slab monitoring was better. But we don't breathe sub-slab air, we breathe indoor air. And so indoor air testing is the most direct method to evaluate vapor intrusion. So the goal of this project was to develop investigation approaches that could accurately distinguish between vapor intrusion and chlorinated solvents coming from consumer products.
Okay, Tom, now you've developed a couple of different approaches for doing this. Now, the first one we're going to focus on today is using an on-site analytical device to get real-time data on air concentrations. Tom, take it away. Mm-hmm.
Yeah, the first approach, which is the most widely used approach, uses a portable GCMS instrument. This is the lab instrument that is commonly used to test indoor air samples, but it's packaged up so you can take it out to a site with you. And so this is an instrument that can detect chemicals at very low concentrations in air, and it uses a mass spectrometer. This is a detector that tells you exactly what chemicals you're seeing in the sample. And by having this instrument on site with you, we can react to the results of one sample in real time and figure out where we want to collect the next sample. Now let's walk through how you'd use this approach. Imagine you're investigating a dry cleaner site that had a release of PCE. That's a dry cleaning solvent. And it got into the subsurface, and we're worried about vapor intrusion at the house next door. In this case, we've already got data from a SUMA sample that was analyzed at an off-site laboratory. And these results triggered the need for further investigation.
So we take our instrument into the building, and the first thing we'll do is test the different levels of the building, the different floors. In this example, we tested the basement, we tested the garage, and then we tested the main floor. And we found out that PCE levels were higher on the main floor of the building.
So next we're focusing on the main floor because that's where we're seeing the highest concentrations. And we test each individual room within that main floor. And we find that PCE concentrations in one specific room are higher compared to the rest of the main floor. So now that room is our main focus. Now we want to use the instrument in real-time mode. We can scan the different storage areas, the cabinets and whatnot within that room, and we'll get an instrument response that in the location that has the consumer product, and that'll let us look inside and find the specific consumer product that's impacting the indoor air. Once we remove the consumer products from the building, we'll commonly collect a SUMA canister sample. This can be analyzed off-site and confirm that chemical concentrations are below a level of concern. Alternatively, when vapor intrusion is occurring in the building, using the instrument we'll commonly find that a specific crack in the foundation or a floor drain is an important pathway for the vapors entering the building. So this confirms that vapor intrusion is occurring, and it also gives us a head start in figuring out a way to remedy the problem to prevent the vapors from coming into the building.
So that's the basic way to use this on-site instrument for diagnosing vapor intrusion issues. I think it's worth briefly mentioning another novel way that can be used to distinguish between indoor sources of these volatile organic compounds and vapor intrusion from groundwater. And Tom, you developed this. What's this one about?
Sure. This method uses compound-specific stable isotope analysis. You collect your samples, and then stable isotope analysis, which is conducted in an off-site lab, gives you a fingerprint on the individual chemical that you focused on. The example shown here plots the abundance of heavy isotopes of chlorine and carbon that you might see in vapor samples of a chlorinated solvent. And you can try to match that fingerprint for the indoor air sample to the fingerprint from the typical consumer product, meaning that it falls within the gray shaded area in the bottom left of example A panel. Or maybe it follows example B, where the isotope signature of the indoor air sample matches what you see in the subsurface sample. So in example B panel, the two symbols for the two samples plot very close together. So by looking to see where you get the closest match, you can determine if the chemical is coming from an indoor consumer product or if it's vapor intrusion. This approach is usually used as a line of evidence along with other conventional vapor intrusion measurements.
Now, Tom, you and your collaborators have integrated all these approaches as part of a smarter way to complete vapor intrusion studies. Let's take a look at those. So if you have a building and you're worried about vapor intrusion, the first recommendation is that you test the indoor air, and you go straight to that indoor air testing, measuring the chemical concentration in indoor air and comparing it to the applicable screening level. And if you're above the screening level, then you need to do additional testing to figure out if this is an indoor source or vapor intrusion.
So that source identification can be done using the on-site analysis we discussed, or maybe even the isotope analysis that we also mentioned. In some cases, you can also modify the indoor building pressure in a way that will turn on and turn off vapor intrusion, and that will help you figure out what's going on.
Very cool. So if you find indoor sources, you remove them, and then you can test them again without those sources. If you're below the screening level, then you move towards long-term monitoring. But if you're still above the screening level, that tells you that vapor intrusion is occurring from groundwater to the subsurface, and you need to mitigate that problem.
Okay, so let's wrap up by revisiting our key points.
We saw the importance of conducting indoor air testing for vapor intrusion studies. We also saw that there are these new methods, these new instruments and devices that are available that help you do on-site analysis easily and accurately.
Yes, when you're trying to do indoor air testing of a building, the real-time data can really help you determine if consumer products or vapor intrusion is the source of the VOCs in the building. It eliminates any confusion in the indoor air data and lets you know for sure if mitigation of vapor intrusion is really necessary.
Well, that's about it. Before we go, I'd like to direct you where you can find more information about this and similar ESTCP projects that focus on vapor intrusion. And remember, this is just one of a number of videos highlighting key results from different CERTUP and ESTCP research projects. Just go to YouTube and search CERTUP ESTCP microlectures to see more of these videos.